Hi Math 141, this video is for section 3.3, graphs of polynomial functions. We're going to take a look at question number 29 from the review section at the end of your chapter. So the function that we're looking at reads p of t is equal to 1 over t squared plus 2t minus 8. And our goal here is we want to determine the domain that we're allowed to use here. So if you notice, now we're looking at essentially a fraction, so a rational function. And we want to know what kinds of restrictions might we have with a fraction. So hopefully you're thinking, well, I know that my denominator can never equal 0. So I would call that out straight away and just say, hey, t squared plus 2t minus 8, this entire expression, which does stand for one number, it cannot be equal to 0. And that's really the only pitfalls that we have to avoid. We can use any other number, or we can use any number, so long as it does not let your denominator equal 0. So what I'm thinking is, well, I do have a quadratic here. So I'm going to try to factor it down. T squared can be broken into t and t. And then what I want to note here is I do have a negative number, so straight away I know that I'm going to have a plus minus here. The plus sign that you're seeing in the middle term is telling you that of the two factors that you decide to work with, the larger of the two numbers has to have the positive attached to it. So when I'm looking at this, thinking of 8, so I need to find two factors that will multiply to 8, but I also want those numbers to sum to a positive 2. So my guess would be, let's go ahead and do plus 4 minus 2. So if you don't believe me, take a moment and FOIL that out and see if we come back to the original quadratic. So now I can actually just get down to the nitty-gritty of it. I'm going to kind of use my zero product property and break it down and start solving for t. So I'm going to get t is equal to negative 4 and t is equal to positive 2. And if you think about this in terms of doing a rough sketch, I'm saying that I have a t-intercept of negative 4, 0 and a t-intercept of 2, 0. If we were to do that on a coordinate plane, in other words, do a rough sketch, here I'm saying that instead of x, my input variable is being represented by t, and instead of y, my output variable is being represented by that function notation of p of t. So if we were to go ahead and graph this, I have my x-intercept here at negative 4 and 1 at 2. I know that because this is a quadratic, or an even degree, I know that my end behaviors are going to go in the same direction. Also note that we were working with a positive 2t, so the lead coefficient is going to be 1, a positive 1. So that means that my end behavior is going to be up, up. And again, what you want to note here is that this has a degree of 1, and this has a degree of 1. So that means that when our function approaches that x-intercept, it's going to cut through it. So we're going to essentially see something like this. And again, it shouldn't be surprising that we essentially did a rough sketch of a parabola. So what I want to note here is, where is everything okay? Well, I definitely am okay here. This gives me output values of a positive variety. My problem is here, so that x-intercept, that would be a no-no. I'm allowed to have a negative number in my denominator, so I can use all these. And then I'm back to that issue of getting an output of 0, so I can't use that. And then I'm back to smooth sailing, because now I'm just getting positive outputs that would appear underneath my radical. So I think we're good to call it then. My domain is going to go from, again, domain is referring to our x values, we're going to go from negative infinity all the way up to negative 4, and this time we're not going to include it. Because remember, if you put negative 4 in for the variable t, it's going to cause everything to zero out. We're going to skip over the negative 4. I can use all the values in between negative 4 and 1. They're going to give me these negative output values. And then I'm going to skip over 1, and I can use everything all the way to positive infinity. I hope this video was helpful. If you do have any questions, please let me know.